Math for College Readiness class, we are looking at 4.1, which is quadratic functions. And in standard form, it will look like this. Y equals ax squared plus bx plus c, a, b, and c all being numbers, of course. And it will make a parabola. Notice it has a x squared. Anytime you have an x squared and no higher exponent, it will create a parabola. Let's take a look at the next screen. You can use the quadratic function to model the heights of projectiles. Here you go. There goes the ball. Okay. It actually is a great way of looking at the parabola, and it's also a great way of looking at quadratic functions. All right. Oops, skip the screen. This is the parent function of the quadratic. The parent function is f of x, or y, equals x squared. Anytime you see that exponent of the square, and that's the highest exponent, it will create a parabola. So here's our parabola, and it looks like a horseshoe. And the parent function's vertex is at 0, 0. And you go over 1, up 1 to make the first point, and go over 2, up 4 to make the second point, because if you put a 2 in here, 2 times 2 is 4, so you get a 4 out. All right, the axis of symmetry is the y-axis for the parent function. Let's take a look at what we can do with this nice little parent function. All right, what happens if we, instead of having y equals x squared, we write y equals 2x squared? What will happen to that nice little parabola? Well, if you're guessing because you remember from the linear functions that this whole number out in front causes things to get closer to the y-axis, you're correct. So what will actually happen is you will make a table with y equals 2x squared. You can do your x's and y's, and you can plot these points. So once you plug in, for example, if I plug in -2, -2 times -2 is 4, 4 times 2 is 8, so I get my output of 8. So you can make a little table to find out what the parabola will look like is this, because when you graph those little points, you get the red parabola. The blue one is your parent function. Notice it got closer to the y-axis, so it becomes more narrow. All right, so that 2 caused the parent function to become more narrow. So let's take a look at the next one. Of course, this is just summing it up. Both of them open up. They both have the same vertex of 0, 0, and the axis of symmetry is the same. It's x equals 0. All right. Now, what happens if we take this nice little parent function and put half x squared, negative half x squared plus 3? Well, the negative is going to flip it upside down, so it's going to open down. The 1/2 will make it open wider, farther from the y-axis, because it's a fraction. And the plus 3 is going to move it up 3. The vertex is going to be at 0, 3. Let's take a look at what they have here. You can make yourself an XY table. I would suggest, of course, you have your 0, 3. That's your vertex because there's nothing with the x, so that's the 0 part, and the plus 3 makes the vertex 0, 3. Now, you go out from there, and you can put any number you'd like, and you get the xy's, and you can create this parabola. And here's the red parabola opening down. Notice the vertex is at 0, 3. And they chose a couple points farther out to create the parabola. All right, let's take a look at another picture. Oh, sorry, I forgot. We want to compare them, so let's talk about how they compare. They have the same axis of symmetry, x equals 0. However, the graph of half x squared plus 3 opens down and is wider, like we said, and the vertex is 3 units higher. All right, let's see if you guys can practice this now. Here's your equation. You're going to graph the function. Obviously, since it's x squared, it's going to create a parabola. Keep in mind that this -4 is going to do something to that beautiful little parabola compared to the parent function. So pause your video and graph this function. And then, of course, make sure you state what happened to the original parent function. Welcome back. Let's see what you guys came up with. Did you notice that the axis of symmetry is the same? It's x equals 0. Here's the axis of symmetry. And then the vertex is right here at 0, 0. Its opening is more narrow because of the 4, and it opens down because of the negative. All right. have you guys try another question here. Please graph this parabola. Make yourself a little XY table. Pause your video, give it a try. Welcome back. Let's see how you did. Did you notice that the vertex went to 0, -5? The axis of symmetry is still x equals 0, and it opens down because of the negative. And you can make your XY table to allow you to create some couple points on either side. All right, one more try. Give this one, please graph this parabola and compare it. Pause your video. Welcome back. Let's see. Did you notice that it opens wider because of the fraction 1/4? It has a vertex of 0, 2, and the axis of symmetry happens to still be x equals 0. Now, here are some properties that we can look at. Let me get rid of this. Here we go. What will happen if we want to move the little parabola away from this symmetry of x equals 0? Here's your standard form. You can use a nice little formula called x equals -b/2a to find the vertex of the parabola when it moves. So, if this a is positive, you're going to notice that it opens up. If this a value is negative, you're going to notice it opens down. All right. All right, here we go. The graph is narrower when you have a whole number bigger than 1 for your a value. It will be wider if this is a fraction. And the vertex will be at -b/2a. That will be the x value for the vertex. And it's also the axis of symmetry. Okay? So the axis of symmetry is x equals -b/2a. The x coordinate for the vertex will always be at -b/2a. So that little formula is really important to memorize. Okay? Now, let's check out where the y-intercept is. It's always going to be at 0c. So this little number that's over here at the end of the equation will tell you where it's crossing the y-axis. All right, things to remember. Here is the parabola in standard form. Now, in order to graph this, we need to use x equals -b/2a. So, we identify the coefficients. This number 2 is a, -8 is b, and +6 is your c. Now, we go ahead and plug it into the formula -b/2a, so we have a 2 once we do the math on that. So, x equals 2 is going to be our axis of symmetry, and 2 is going to be the x value for our vertex. So, we put the 2 in to find out the y value is for our vertex into the original equation. So, you do 2 squared times 2 minus 8 times 2 plus 6 equals -2. So, our vertex is going to be at 2, -2. We can plot our vertex, and we can use an XY table to create the parabola. So, axis of symmetry, vertex is right here, and we create our parabola by using a point to the right and to the left of it. Now, we know it's going to cross the y-axis at, let's go back to the original equation. Oops, come on. It's going to cross the y-axis at 6, okay? So look, it crosses the y-axis at 6, and we can use 6 as a point, and we can get over 4, 6, and we have 0, 6 as a point to help create our parabola. You usually need at least the vertex and 2 points to the right, 2 points to the left for your creating your parabola on your XY tables, okay? All right, when you draw the parabola, it looks like this. Vertex at 2, -2, axis of symmetry, x equals 2, and you have your 2 points. All right, I would like you guys to try these. Remember, the -b/2a, x equals -b/2a, is important to get your axis of symmetry and also your x value for your vertex. When you want your y value for your vertex, just plug in your x value into this nice little equation, and then make yourself an XY table to create 2 points to the right, 2 points to the left of that vertex. Pause your video and give number 4 a try. Welcome back. Let's see how you did. Could you create this beautiful parabola here? You have 1, -2 is your vertex, and then it crosses the y-axis at, oops, that's a bear, -1, and then you create to the right and to the left. Try number 5. Pause your video, give it a try. Welcome back. Let's see how you did. Now you will notice that your vertex is at negative 1/2, negative 1.5, sorry. And your axis of symmetry is at negative 1.5, and you can plug points into the right and to the left into the xy table, plugging it into the equation to get other points. It will cross the y-axis at 3, okay? All right. One last one for you to try. Pause your video and try to graph this function. Welcome back. Let's see. First of all, we have negative b over 2a. Ooh, this one's not pretty. All right, so you'll be excused from having to graph this one. All right, I have one more video to show you guys, and I'll be back.